I hope you're fine. I hope all these things is going well with you. Once again, I would like to talk about my researchers and findings in the field of optimization algorithms and models. Previously, I provided some details for NP-hard optimization problems and recent heuristics like red deer algorithm and social enduring optimizer. Now, in that section, the goal is to improve on metaheuristic. How we can innovate a new optimization algorithm based on modifications or hybridizations for metaheuristic. What are the challenges to the field? And what are the solutions? How we can create a new hybrid metaheuristic, or how we can modify the operators for a metaheuristic to propose an improved version. Having contribution in the solution algorithm like metaheuristics, when you want to solve an NP-hard problem, is very significant and important. As an editor or reviewer in high-ranked journals, personally, I generally expect to see a contribution in the solution algorithm. This is why all researchers in this field need to know that how they can create a new hybrid or modified metaheuristic. To this end, I would like to teach you how we can create an efficient hybrid algorithm based on the combination of red deer algorithm, as we previously discussed, and genetic algorithm, a very well-known traditional metaheuristic. As such, I would like to teach you how we can modify the operators of social engineering optimizer to create a modification. What are the adaptive theory for an improved for the creation of an improved version? In this regard, I will show my papers and all such the MATLAB codes, and hope they are useful for you. Let us start. In this regard, let me share my screen. Yes, the first paper that I would like to talk to you about is a recent published paper in the area of supply chain network design. In this paper, I have developed two hybrid metaheuristic algorithms for a supply chain network design model, and I have proposed the red deer algorithm and its hybrid version. When you want to create a hybrid version, you know that the main things is to work on two items. First, we need to improve the performance of the algorithm. All metaheuristics have the two search phases, identification and diversification phases for the search a new solution. And also, it should be noted, we need to improve the quality, as well as we need to improve the computational time. It is very important to get a solution as soon as possible, and it must be the optimal solution in comparison with the original algorithm. For the creation of a hybrid algorithm or a hybrid metaheuristic, generally one algorithm should work as the main loop. It means that we want to do some modifications, or we want to change some operators in the main algorithm. And for this modification, we can use other metaheuristics. Generally, in hybrid algorithms, we use some benefits and from traditional algorithms, such as the genetic algorithm, simulated annealing, taboo search, and variable neighborhood search, or several low-cost search techniques to improve the main loop of resident metaheuristic. I think if due to time, I cannot provide all details for the red deer algorithm. If you want to see more details for the red deer algorithm, I encourage you to see my previous video for the red deer algorithm.
Whether you're building dynamic network models or forecast,
this video is useful if you want to understand red deer algorithm. In the red deer algorithm, we have 3 main operators for roaring red deers, male red deers, operators for fighting between 2 male red deers, and the mating process. The mating process in the RDA have many steps and procedures, and all commanders should mate with hinds in the harem or out of the harems, and also mate their stacks. In this hybrid algorithm, in this paper that I am talking about, I removed the part for the mating stacks with the nearest hind. I think it is useful to reduce the computational time of the red deer algorithm, and also I only kept the mating operator, and in this regard, I have used the crossover operator in the genetic algorithm for mating commander and hind. In this regard, I selected the hinds randomly, like the genetic algorithm. In genetic algorithm, the parents are chosen randomly. It is not, there is no guarantee that all parents, or for example, all commanders or hinds should be mated. No, only some solutions or some parents are chosen randomly. And in this hybrid version, I did this procedure. In this regard, let me talk about the MATLAB codes for this hybrid algorithm, for the hybrid of as the purpose hybridization of RDA and GA. Like always, you can find the codes for my papers in the ResearchKit file. You need to search the paper. After, you can find the paper and see the data, link of data for the paper, and you can see the hybrid RDA and GA. And now I would like to download these codes. And I can extract it to a new file. And let me, I have in this code, I provide both RDA and the hybrid RDA. And I can compare the codes and what I've done for the creation of this hybrid algorithm. So in the general or in the original Redder algorithm, we have roaring and fighting and the forms of harems and also the mating. And the mating is very huge because we need to mate both commanders and stacks. However, in the hybrid algorithm, to reduce the computational time and also to keep the performance of the Redder algorithm, I removed the mating process for the stacks, and also I have choose the hinds randomly. In the original RDA, the hinds, all the hinds are chosen, and there is no random process to choose the parents. However, in the hybrid version, you can see that I have chosen the hinds randomly, and also only the commanders can do the mating, and there is no mating for the stacks. So we can run the codes, and you can see it's working very well. You can see that the computation time is around 14 seconds. And the quality of solution is very good. I think it's it's very close to 0 as the global solution. However, in the original RDA, we can see, let the algorithm will be done. As it's clear, the computational time of in comparison with the original algorithm has been improved. Therefore, the HRDGA is faster than RDA. And also the quality of the solution is very close. It means that if we run the algorithm several times, we can see that there is no difference between the performance of RDA and its hybrid versions. They are very close. Both of them are strong. However, the hybrid version is faster. Then we have used some characteristics from genetic algorithm. This option let us have a faster algorithm, which is also intelligent, similar to the Redder algorithm. So let me to talk about another paper. In this regard, as I told you, I want to talk about the modifications for the social engineering. There are many versions, and I think the best way that I want to select paper, which was published 2 years ago, and this paper, novel modifications of social engineering for traffic scheduling. In this paper, I have developed many variations of the social engineering based on heuristic rules, and then I applied a traffic scheduling problem and different benchmark tests for the for both for different optimization problems to have a very great comparison. I previously discussed about the social engineering, and similar to the Radir algorithm, you can see the I hope yeah, I mean this file. If you see this file, you can see all details for the social engineering, and there is no need to talk about them here. Therefore, I want to focus on the modified version. The modified version for the social engineering, there are many, you can read them. Now I want to focus on the third version for the modified social engineering. In this version, I have provided a heuristic rule for updating the number of attacks in per iteration. It means that we should calculate the number of successful attacks, and then based on the number of successful attacks and then the current iteration, we can update the number of attacks. Well, this heuristic rule can help us to reduce the computational time. There's no need to have the same iteration to have the same number of attacks in each iterations. The number of attacks can be reduced or increased based on the number of successful attacks. It means that when a social engineering technique is successful, we can focus on them. And in this regard, I have provided this new modified version. So let me copy the title of the paper, and the codes for the modified version is available. It's available in the research guide. This is the third version. I want to keep it here, and now we want to search the modifications of the social engineering and the codes. The codes is available for the third version is here. We can download the codes. So let me extract the file. And once again, you can see the modified M cell and the generous cell. I open both files to show you how we can provide this comparison. So for the social engineering, this is the social engineering attacks that for the number of attacks and per iteration, it's a fixed value, and we can see that the social engineering rules are provided, and then the social engineering texts are done. In the modified version, as given in the paper, I have defined a matrix for the number of success, and if the defender has been improved during the attack, I considered this attack as successful. Therefore, it is equal to 1 for this success. And in this, and now I updated the number of attacks per iteration. So the number of successful attacks is calculated as follows: the summation of success, and then the number of connections or number of attacks is updated regarding this formulation. As you can see, this is formulation in the main text. You can see here, this is a adaptive heuristic formulation to update the parameter heuristically. And you can see that I updated the parameter of number of attacks, as you can see it in the codes. So yeah, first of all, let us run the main codes for the social engineering optimizer. Yeah, you can see that it is fast, but let us see what is the computational time and what is the final solution. Yeah, the final solution and the computational time is around 14 seconds. The final solution is 2. This is very close to 0. And now I want to run the modified social engineering optimizer. It is round, and yeah, let us see what is the computational time and what is the solution, and which one is better. So yeah, this error is not for the main lookup algorithm. It is for the spectrum. It is because we update a matrix per iteration. This error is happening, but because it is, yeah, as you can see, it's errors related to the size input contains for the matrix, and you can see that the computational time and the final solution for the modified version, both algorithms are highly strong, and the modified version is a bit faster, and that is why, yeah, this is why it's very interesting for us to have a new modified version. Yeah, all in all, it is very important to create a hybrid metaheuristic or an improved or modified version, because there is always a better algorithm than the original algorithm. It's also important in all papers linking to the NP-hard optimization problem when you apply metaheuristics. Nowadays, many journals expect a good contribution for the solution algorithm, and that is why you can that is why you can create an innovative metaheuristic base to do some modifications or hybridations to have this end. I hope you have enjoyed, you have used this information for the hybrid metaheuristic or modified metaheuristic. And like always, you can ask me your questions by email. And also all the codes that I have around are available in the ResearchGate. So you can download the codes, you can download the papers, and you can use them in your future works, in your research papers. All in all, have a nice day and hope everything is well with you. Take care of yourself. Nowadays, the COVID-19 pandemic is very close to the end point, and I hope all researchers are now able to back their labs or back to their office. Have a good day and bye. Let me provide